So we have an NTC thermistor. We're trying to see how resistance varies with temperature. So first of all, that should look, for an NTC thermistor, it should look like this. We will be plotting a graph of resistance against temperature because temperature is the independent variable, that's what we're changing, and then resistance is the dependent variable, so that will go on the y-axis. The resistance depends on temperature, therefore it's the dependent variable, so we put it on the y-axis. And then we're trying to get a set of instructions that the student could follow and a safety precaution. Okay, so I guess the first thing that we could think about is how we are going to change temperature and how we are going to measure resistance. Let's start with the temperature. So to vary the temperature, what we could do is, there's a few things we could do. We could start with a beaker of water, put some ice in it, like a bunch of ice in it, and then it should be close to 0 degrees Celsius. And then we can gradually warm up the beaker of water and ice until it reaches close to 100 degrees Celsius using a Bunsen burner. And inside this beaker, you will have the thermistor and you will have the thermometer. You can measure the resistance of the NTC thermistor using an ohm meter. All right, so let's write some of that stuff down. So we could increase our temperature in let's say either approximately 5 or 10 degree intervals. Whenever we have increased the temperature, we can turn off the Bunsen burner, we can allow the heat to distribute throughout the water, and with the aid of a stirrer, which could also potentially be the thermometer, we can ensure that the heat is evenly distributed across the container. When we are reading the thermistor, we want to make sure that we don't get a parallax error. And a parallax error is when you view a thermometer or a ruler at the wrong angle, and therefore you get the wrong reading. And now we can mention our plotting of the graph. So the final thing that we need to include in this is our safety precaution. And there's a bunch of different things that we can have. So we could wear goggles to make sure that if hot water splashes, it doesn't go into our eyes. We could also have the beaker in or clamped in some kind of stand so that it's less likely to topple over if it gets knocked. Okay, so for the next part, we have the student's results. So we have resistance against temperature. We have a bunch of points plotted. And the question is asking us to give 2 modifications to the experiment that could improve the results. So a couple of things. We don't have a large range of data. We don't have any data between 0 and 20 degrees Celsius, and we don't have any data between 80 and 100 degrees Celsius. So we can increase the range of temperature values over which we take resistance readings. So that could be 1 point. And the second point, if we look at this part of the graph here, notice how there's quite a large gap between each of these readings. So if we were to take more frequent temperature readings, so let's say every 5 degrees Celsius instead of every 10 degrees Celsius, that would decrease the gaps between those points and then result in a smoother curve that could then be plotted. So as you increase the temperature, the ions inside the thermistor will gain energy, and the electrons that are bound to those ions will also gain energy and can then jump from the valence band to the conduction band in our semiconductor. And when they do so, they are then free to move around as current. So this increases the charge carrier density. It increases the charge carrier density significantly. Now, if you remember what happens to a filament lamp when you increase temperature, the metal ions in that filament lamp also gain energy, and that will then mean that they vibrate with a greater amplitude. And if you remember, that actually decreases the current in our circuit because you have more collisions. Now the same thing is happening here to an extent. You will have your ions inside the semiconductor vibrating with a greater amplitude, and that will increase the rate of collisions, but that effect is outweighed by the increase in the charge carrier density. So the charge carrier density increases significantly enough such that the increase in current that causes outweighs the decrease in current, which would be caused by the greater rate of collisions with ions as they vibrate with a greater amplitude. You don't have to write all that down. The main thing to write for this first point is that as the temperature increases, your ions gain energy, and that increases the charge carrier density. So let's write down that first point. And if the charge carrier density increases, that increases current, because I is equal to NAVE. So then for a given voltage, if the current were to increase, if we consider V is equal to IR, R is proportional to 1 over I, and so if our current increases, the resistance will decrease.